For as long as life has existed, living organisms have battled cancer. Long ago, the Earth contained natural cancer-causing agents like ultraviolet radiation from the sun and certain minerals in rocks. Over time, living things adapted to these dangers. However, when humans began creating new chemicals, we introduced a vast number of man-made cancer-causing substances, or carcinogens, into the environment. Unlike natural carcinogens, our bodies have no natural defenses against these new threats. The link between environmental agents and cancer has been understood since the 18th century when Sir Percival Pott discovered that chimney sweeps were more likely to develop cancer due to soot exposure. Since then, we've learned much more about how chemicals can cause cancer. In modern times, industrial chemicals have added to this problem. The result is a significant increase in cancer cases, affecting not only workers in hazardous jobs but the general population as well. Today, cancer is a leading cause of death in the US. More children die from cancer than any other disease, a sharp contrast to the past when childhood cancer was rare. Scientists now believe that exposure to cancer-causing chemicals in the environment, including pesticides, plays a role. Some of these chemicals can pass from mother to child during pregnancy, potentially leading to cancers that appear later in life. Many pesticides have been linked to cancer in both animals and humans. For example, arsenic, which has been used in pesticides, has been known to cause cancer for centuries. In areas where drinking water was contaminated with arsenic, cancers of the skin and other organs became common. Other chemicals, such as DDT, have also been associated with cancer, even though they were once widely used in agriculture and homes. Sometimes, chemicals don't directly cause cancer but disrupt the body's normal processes, leading to conditions where cancer is more likely to develop. For instance, some chemicals damage the liver, which helps regulate hormone levels. If the liver can't function properly, hormone imbalances can increase the risk of certain cancers, such as those in the reproductive system. The rise in cancer cases isn't just due to direct chemical exposure but also to the way chemicals interact. A person exposed to multiple low doses of different chemicals might face greater risks than previously understood. This highlights the need for stricter regulation and better understanding of how chemicals affect human health. The increase in cancers, especially in children and younger people, suggests that the problem is growing. While efforts to find a cure for cancer continue, preventing exposure to harmful chemicals could be a more effective way to reduce cancer rates. Unlike natural cancer risks, man-made chemicals are something we can control, and reducing them could significantly lower the number of future cancer cases. Humans have tried to control nature, especially insects, with chemicals, but our efforts have often backfired. Nature is complex and resilient, and insects have found ways to survive and thrive despite our chemical attacks. In fact, many insects are now developing resistance to these pesticides, making them harder to control. One of the biggest mistakes we've made is overlooking the natural balance in ecosystems. Insects are controlled not just by chemicals but by other natural forces, such as predators, competition for food, and environmental conditions. When we use chemicals that kill both harmful and beneficial insects, we upset this balance, allowing some species to grow out of control. For example, after years of spraying crops with pesticides, some insect problems that seemed to be solved have come back even worse. In some cases, insects that were once considered minor pests have become major problems. This happens because chemical sprays don't just target specific pests, they can also weaken the environment's natural defenses. The natural world has built-in checks and balances. Predators like ladybugs, dragonflies, and parasitic wasps help keep harmful insect populations in check. These predators are often more sensitive to pesticides than the pests they prey on, which means that spraying can wipe out the predators, allowing pests to multiply rapidly. In one famous case, the US Forest Service sprayed DDT to kill the spruce budworm in western forests. The following year, spider mites exploded in numbers and damaged vast areas of forest. This happened because the spraying killed off the natural enemies of the spider mites, allowing them to spread unchecked. The same thing happens in agriculture. In apple orchards, for example, spraying pesticides led to an outbreak of the red-banded leaf roller, a pest that had never been a problem before. Spraying not only failed to control the pests but also created new, more serious problems. These examples show that chemical control methods often create more problems than they solve. Nature has its own methods of keeping insect populations in balance, but when we interfere with these systems, we make things worse. Some scientists and farmers have realized that working with nature is more effective than fighting against it. For example, in Nova Scotia, farmers found that using fewer chemicals and relying more on natural predators resulted in better crop yields and fewer pest problems. This approach, called biological control, uses the natural enemies of pests to keep their populations in check. Unfortunately, chemical companies have pushed pesticides as the main solution to pest problems because it's profitable for them. They fund research and promote the use of chemicals, while biological control methods, which don't offer the same financial returns, receive far less support. To truly control pests and protect our environment, we need to recognize that nature's methods are often more effective and less harmful than chemical solutions. By understanding and respecting the balance of nature, we can find better ways to manage pests without causing further harm to the environment. If Charles Darwin were alive today, he would be amazed to see how quickly insects are evolving to survive the chemicals we use to kill them. As we spray more pesticides, the weaker insects die, but the stronger ones survive and pass on their resistance to future generations. Over time, this creates a population of insects that are nearly impossible to kill with the same chemicals. This problem of resistance has been building for decades. In the early 1900s, scientists first noticed that certain insects, like the San Jose scale, were becoming harder to kill with pesticides. By the 1940s, when new, stronger chemicals like DDT were introduced, the problem grew worse. Insects began developing resistance at a much faster rate. By 1960, over 100 species of insects were resistant to multiple pesticides, and the number continues to grow. The issue is especially concerning when it comes to insects that spread diseases, like mosquitoes and flies. Mosquitoes, which carry malaria and other deadly diseases, are becoming resistant to the chemicals that once controlled them. In some parts of the world, malaria is on the rise again because mosquitoes are no longer affected by the sprays used to kill them. Other insects, like flies that spread diseases through food contamination, are also becoming resistant, making public health efforts more difficult. In agriculture, the same problem is happening with insects that destroy crops. Many pests, like the codling moth that damages apples, have developed resistance to the chemicals farmers have relied on for years. As a result, farmers are forced to use more and stronger chemicals, which only makes the problem worse in the long run. The chemical industry has been slow to address this issue. Instead of finding safer and more sustainable solutions, they continue to develop new, more toxic chemicals. But as the problem of resistance grows, it becomes clear that we cannot rely on chemicals alone to control insects. We need to explore alternative methods, such as biological controls, which use nature's own predators and parasites to keep pest populations in check. Ultimately, the way we've been fighting insects is leading us down a dangerous path. The more we use brute force to try to control nature, the more we disrupt the delicate balance of ecosystems, creating even bigger problems. It's time to rethink our approach and find smarter, more sustainable ways to work with nature instead of against it. We now face a choice between two paths. The one we've been traveling is fast and easy, like a smooth highway, but it leads to disaster. The other road, though less traveled and more challenging, is our last chance to protect the Earth. We have relied on chemicals to control insects, but this has come with great risks. There are alternatives, however, biological methods that work with nature instead of against it. These methods have had successes in the past and hold even greater promise for the future. One promising technique is the male sterilization method, where large numbers of sterilized male insects are released. These sterile males compete with normal males to mate, but since they produce no offspring, the population eventually declines. This method was used successfully to eradicate the screwworm fly, a major pest to livestock, in Florida and the Caribbean. It showed that science and creativity can find solutions that don't rely on dangerous chemicals. Other biological methods include using natural enemies, like predators and parasites, to control pest populations. In the forests of Germany, for example, red ants have been introduced to help control harmful insects. Birds, spiders, and small mammals like shrews can also play a role in keeping insect populations in check, providing long-term, natural control that chemicals can't offer. There are also new approaches, such as using chemical attractants to lure insects into traps or using bacteria to target pests while leaving other species unharmed. These methods don't harm the environment and can be more effective than chemicals, which often only provide temporary solutions and create resistant insect populations. The widespread use of pesticides has ignored the complexity of nature and the delicate balance that sustains life. Instead of continuing down this dangerous path, we must explore biological controls that offer safer, more sustainable ways to manage pests. The solution lies in respecting nature and working with its processes, not trying to dominate it. In the end, we must choose the road that leads to the preservation of life. The current path may seem easier, but it will destroy the very systems that support life on Earth. The other road, though more difficult, is the only one that can save us and our planet.